Meta surfaces are commonly used for parametric sweeps along a given path, direction or range. When sweeping any kind of curve definition, the surface shape can be further controlled by multiple curve parameters. Examples of applications are volutes, ship hulls, blades, diffusers, wings, ducts and many more. Typically, these kinds of surfaces can be based on a 2D contour, or profile description which consists of a set of parameters like radius, length, angle or an area value. Meta surfaces control such key parameters by functions along the sweeping range. Finally, such functions are then varied in design studies and optimization processes. The process is as followed. The 2D profile is designed first with a single length parameter called P1. This curve is then encapsulated in a feature definition. In a next step, a function is created that controls the values of P1 within the sweeping range. The profile and its functions are then connected by curve engines. Finally, a meta surface is created which is based on the curve engine. In this tutorial a simple spiral gets modeled. Surface generation is based on a circle, that is, this will be the curve definition, for which the sectional area is controlled in the circumferential direction. Additionally, the spiral radius is introduced and controlled to receive a typical spiral shape when smoothly decreasing its value. The single steps of this tutorial refer to the illustration previously. Step 1 and 2 focus on the circle definition. The circle has to be moved to the starting position of the upcoming surface using a translation. Secondly, the rotation around the y-axis is defined. Simple functions are created for the area parameter and the spiral radius to control the shape in the circumferential direction. Some comments on the meta surface attributes are also given, so as to understand the surface attributes and fine-tune the final shape. In the first step, a circle is created. The radius will be controlled by a user-defined parameter for the area. Create a parameter by going to CAD, Parameters and click Parameter and name it Area. For a start, set the value of area to pi, with open and closed brackets after and divide it by 100. Create a circle via CAD, Curves, and click Circle and name its section. The area of a circle is given by area equals pi times the radius square, so enter the following expression into the circle attribute radius. You can now change the area parameter and the radius will be set accordingly. The circle will be rotated around the global y-axis during the surface generation process. We need to translate the section to the right place in space to start the sweep. For the total transformation of the section, a translation and a rotation are required. Both are combined in a transformation chain. For section, create a transformation chain via the pull-down menu of the attribute, Transformation. Set the name of it to Total Move. From the pull-down menu of the attribute, Transformation Chain, of Total Move, create a translation and name it Delta. Set the dx value of delta to 1. Again for Total Move, from the pull-down menu of the attribute, Transformation Chain, create a rotation and name it Rotate, by clicking the plus button, and then into an empty editor field. Set the value of angle to 45. Set the rotation attribute axis to Y. Close all but rotate by clicking at the white button in the upper right corner of Rotate. Create a parameter alpha for the attribute angle via the context menu. Change the value range from 0 to 360 degrees. Click Section and add the transformation chain total move, to see the transformation in the 3D view. Change the alpha value to see the transformation. The circle section can be rotated around the y-axis and the area value controls the radius of the circle. Let's put this curve into a feature definition which will be the input object for the upcoming curve engine. Select all objects in the tree, apart from the parameters area and alpha. These values are variable so they will be inputs for the curve definition. From the context menu, select Create Feature Definition. Set the type name of the definition to Spiral Section. Press the Apply button and close the dialog. Create a feature from the new definition by right-clicking and name it Test. Check whether everything works fine and enter some test values for alpha and area. Now that we have created the feature definition, we no longer need the initial geometry. Let's put it into a scope and hide the geometry for the time being. Note that we could also delete the initial geometry. Select all objects and create a scope via CAD, Scope. Name the scope Design. Now we can create parameter distributions for the variable input of the section definition, namely area and alpha. Remember, the goal is to vary the area in the circumferential direction. Angle alpha shall run between 0 degrees and 360 degrees, in a linear manner. For this example, we want to define normalized functions in the xy system, that is the x-axis is the abscissa and y-axis the ordinate, both in the interval within 0 and 1. Create a line via CAD, Curves and select Line, and name it alpha function. Set start position to 0, 0, 0. Set end position to 1, 1, 0. For the area distribution we want to have a simple B-spline curve that is defined by a set of 5 points. Choose CAD, Curves, More, then click Planar B-spline Curve from the B-spline menu. Set number of control points to 5. Set constant value to pi, with open and closed brackets and divide by 100 for a reasonable initial constant function. Note that there is a preview in the 3D view of your entered values when the preview box is selected. Press the Execute button of the dialog so that the B-spline curve gets created in the tree, in the scope, F1. Rename F1 to Area Function. In this step, the 2D section definition and the parameter distributions are connected using a curve engine. Choose CAD, Curves and select Curve Engine, and name it Engine. Set spiral section at the attribute definition of the curve engine. Now, the available feature arguments alpha and area are shown in the interface and the inputs can be set. Use either drag and drop or the pull-down menu of the attributes. Set alpha function for attribute alpha. Set the curve from scope area function for attribute area. we model the distributions in a normalized system. The function for alpha will therefore return values from 0 degrees to 1 degree, ordinate range, but we need to have a range of 0 degrees to 360 degrees, insert a multiplication factor right after the curve that is, alpha function, 360. The values from this function will then be scaled by 360. So far, the curve engine has all the information for returning a curve in the abscissa range, 0 and 1, since the 2D circle definition and its distributions are defined within this range. From this information, we can generate a surface, select the curve engine, not really required but convenient since the next step will include this selection by setting the engine for the meta surface. Choose CAD, Surfaces, and select Meta Surface and name the new surface spiral. Let's modify the area distribution as a demonstration. Select the points of the area function, in the scope area function, and auxiliary, and move them in the Y direction in the 3D view to change the area distribution of your surface. Note that this is typically what a design engine does in an automated process via design variables for the X and Y coordinates of curve points. Let's have a look at the base positions and some fine-tuning attributes of the meta surface. Base positions: identify the surface generation range that corresponds to the abscissa values of your coordinate system. In our case, our definition range, where the distributions are given, is from 0 to 1, which is also set in the two base positions, respectively. Change the values, for example from 0.5 to 0.75 in order to generate a surface only in this range. NURB surface generation: the meta surface entity needs to be converted into a common CAD entity so that it can be exported, for instance in IGES format. Meta surface positions get interpolated and a NURBS surface is generated. This is what you finally see in the 3D view. You can control the surface interpolation by using the two input attributes for number of points in curve direction and surface direction. If you click at the NURB surface generation category header, the attribute representation is shown. It controls the way of interpolating the point data. As a final task, we want to introduce another parameter which controls the circumferential radius so that we receive a typical spiral shape. Double-click the Feature Definition Spiral section in the tree, Node Feature Definitions, in order to edit the section description. Add another argument with name radius, choose double to be the type and a default value of 1. In the Create function, replace the fixed value 1 of delta.setDx, 1, with the radius. Press Apply and close the dialog. Select Engine in the tree and try different values for the new input radius. The new radius parameter is introduced, so we still need to create a function and connect it to the spiral. Copy and paste the scope area function and name it radius function. Select all points in there and set the Y coordinate to 1 as a starting point. Select Engine and set the new input curve for radius. Select point 3 and point 4 and set the y-coordinate to 0.5. Interactively, pick a point of the radius function and drag it in the y direction.